Okay, everybody. So let's take a look at the sheet that says, "Am I up for a challenge?" Okay, everyone. So the difference quotient, as I mentioned, you're actually going to use that quite a bit in pre-calc and calc. So this is actually right here. This is the thing called the difference quotient.
Oh, I've seen this.
You have?
Yeah. Oh, yeah. Oh my God, sorry.
Oh, thank you. Oh, I love it.
So basically what it does, ladies and gentlemen, it's going to help me find the slope of a secant line for a given secant line. So for example, let me give you a quick sketch. You don't have to draw this if you don't want. If I have some function f, right? So let's just say f looks something like this, right? I have some random point here, and then I have another random point here, let's say. The secant line would be the one that sort of connects those 2 points. Okay, so the coordinate for this first point would be at some value of x, and then when you plug it into the function to get the y, wouldn't that be an f of x? Right? If you plug in x, whatever comes out is the y value or f of x. So there's that point, and then this next point is going to be some distance h units away. So it'll be at some x value, that's x plus h, and then its y value would be f of x plus h. Okay, so basically what I'm doing is I'm finding the slope between those 2 points, and the difference quotient will do that for me. Now, when you get into pre-calc and calc, you'll talk about limits, and you'll eventually be taking the limit as these 2 points get closer and closer and closer together, so you can find an instantaneous slope at a given point. But for now, we're just going to use the difference quotient, and the formula is there, so, and you already know how to work with functions like this. So let's try it. So for this first one, I need to do f of x plus h. So remember what we do. Whatever is inside the parentheses, you're going to go to the function and you just replace x with whatever is in there. So for f of x plus h, I'm going to make a little list right here. F of x plus h, wouldn't that just be -3 times x plus h minus 4? Or just that chunk? Right? Do you agree? F of x plus h. Now I can go ahead and simplify this. So that's a -3x minus 3h minus 4. F of x, I already know what it is. There's nothing else that I need to change there. I'm just going to subtract all of it, and then I'll divide the whole thing by h. So now let's kind of put all the pieces together. So I'm just going to rewrite the difference quotient here. It's helpful. The more you write it, the sooner you'll remember it. So let's pop in all these pieces. F of x plus h, we just did that and we found out it was -3x minus 3h minus 4. And now I need to subtract from that all of f of x. Now be careful, f of x is a binomial, so you need to subtract all of it. So I put it in parentheses, I'm sorry, for a reason, right? I need to subtract all of this, so I'll have to distribute that negative. And then in my denominator is just an h. So let's kind of simplify this and see what comes out. -3x minus the 3h minus 4. Now we'll have a plus 3x and a plus 4 all over h. Let's continue to simplify and see what happens. The negative 3x and the positive 3x are going to cancel. A negative 4 and a positive 4 are going to cancel. And I get negative 3h over h, which doesn't that just simplify to be negative 3? Ta-da! How do we feel? Okay-ish. So the bottom, you'll see it's basically the same thing, just instead of an h, we have a delta x. Okay, you guys have heard of that triangle thing as delta, right? Okay, cool. So let's try with the bottom. I always like to do the first chunk sort of on the side before I put it into the whole thing. So if I'm going to do g of x plus delta x, I'm doing x plus delta x squared plus 2. Okay, let's go ahead and do that out. X squared plus 2 x delta x plus delta x squared plus 2. Okay, so now that we have this, go ahead and pop it in and see if you can simplify and see what comes out. Again, make sure you're subtracting all of the g of x functions. So you should have a minus x squared and a minus 2 once you do that part out. Okay, do we get lucky again and having a whole bunch of things cancel? Some things. X squareds go, positive 2, negative 2 go. Can you simplify any further than that? Yes, since everybody has a delta x, at least one of them, we could reduce it from all the pieces. So I'd be left with 2x plus one of these delta x's would reduce out, but one would remain. And that's it, over 1 if you wanted. And there is my answer. Pretty cool, huh? I thought you'd say so. All right, so let's take a look-see-loo at the other sheet that I gave you. Okay, let's do one like number 2 together. How about that? Let me give you a minute to try it, and then we'll sort of do it out together. How'd this one go? Maybe I picked one that was too easy, unless you're thinking, what do you mean this is too easy? I have no idea what I'm doing. Okay, so I'm gonna start doing this one out. So again, I need to figure out what f of x plus h is to sort of kick things off. So all I have to do is replace the x with an x plus h. All right, that wasn't so bad. I already know what f of x is because it's just square root of x. So I'm just going to subtract those two and then divide it by h. So I'll take my f of x plus h, square root of x plus h, minus f of x, which is just square root of x, and the whole thing is just divided by h. Can you simplify this any further than that?
Can you separate the x of x plus x plus h?
So you want to do square root of x plus square root of h? Is that what you mean? You can do that when it's multiplication. If I were multiplying x and h together, you could definitely split them. But with addition, I can't, unfortunately. So I claim you can't go any further than that. You're done. So sometimes they are what they are. Let me look for one that's not so easy. How about let's do 4. Let's do 4. That one's got some oomph to it. So again, I'll give you a moment. Give you maybe another minute here. Does anybody think they have an answer for 4? Evan, what'd you get?
I got h plus 2x minus
H plus 2x and then what?
minus
Minus 1. Anybody else have an answer? Or got the same thing? Well, it is correct. So let's see how we arrive here. All right, so first we need to do f of x plus h. So let's see what that gets us. So remember, anywhere you see an x, you are now going to replace it with x plus h. So that means I have x plus h squared minus x plus h. Make sure you're going to subtract all of that. It's 2 pieces. It's a binomial, so you have to subtract all of it, not just the x. And then I have this plus 5 on the end. Okay, so let's simplify this and at least get that first chunk. So x plus h squared would be x squared plus 2xh plus h squared. Okay, then we'll minus x minus h plus 5. Oh, tricky. Be careful. Now let's see. What cancels? Anything? Oh gosh, nothing. Right? Nothing yet. So, all right, there is f of x plus h. That's a doozy. So what I'm going to now do is I'm going to take this and I'll pop it into my difference quotient. So I have that and then I'll minus f of x from it. Okay, so I'll do that right here. So here's f of x plus h minus x minus h plus 5. Now I need to subtract from that all of f of x. X squared minus x plus 5. So when I distribute that negative, I'm going to have all those signs are going to flip and the whole thing will be over h. Okay, so I get x squared plus 2xh plus h squared minus x minus h plus 5 minus x squared plus x minus 5. And now I should have a bunch of things that cancel. All over that h still. All right, let's see what goes away. X squared and negative x squared. Negative x and positive x. And a positive 5 and a negative 5. So now, and I think that's it. So now I'm here. I'm at 2xh plus h squared minus h all over h. Since all 3 of my pieces, well, really 4, right? All of these and these have a common factor of h, I can reduce everybody by h. And that is exactly how we get 2x plus h minus 1. Da, 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 da. Did you get it? If you didn't, did you find where you went wrong? Did you forget to distribute a negative? That's such a common mistake, so be careful. Okay, I think maybe one more together. Maybe we should do one on the back. Gosh. Maybe you want to do one of the fraction ones on the back, like 10? Okay, let's do 10 together. You try it, and then we'll go through it together. This one's a bit of a doozy. Bless you. Okay, how did we do here? Trickier. I'll tell you one version of the right answer. You might have multiplied out the denominator, but I didn't. So did anybody happen to get -1 over x plus delta x minus 2 times x minus 2? You did?
How did you get the -1?
Let's find out. Okay, let's do this one together from scratch. So first we need to do g of x plus delta x. All right, let's see. So I'm going to take the function and I'm going to replace x with x plus delta x. That'll be 1 over x plus delta x minus 2. Okay, so there is that first piece. So now I'm going to take that, I'm going to subtract the original function, and I'm going to divide the whole thing by delta x. Yeah, so far are we okay? Is this part fine? Did everybody get that for that piece? You took x plus delta x, popped it in, you'd have that. All right, let's take that 1 over x plus delta x minus 2. And I need to now subtract the original function, which was 1 over x minus 2. The whole thing has to be divided by delta x. So now I'm here. Were you here too? Okay. So, oops, I went the wrong way. I want to zoom in a little bit. All right, now I have this complex fraction. So do you guys remember how to handle complex fractions? Evan, what do you do?
You multiply denominators of the ones on top.
Yeah, you look at all your little fractions inside this complex fraction and figure out what the common denominator is. So this one, if you, I mean, you could put it over 1 if you wanted, just so that it's a fraction too. So now if I look at all of the denominators of the little fractions, my common denominator is literally going to be this whole thing times this whole thing. You see that? There's no like shortcut here. So what I do is I'm going to multiply everybody by x plus delta x minus 2 times x minus 2 on top, and I have to do it on the bottom. X plus delta x minus 2 times x minus 2. Because remember, this over this is really just 1. That's why I'm allowed to do this. Because I'm multiplying the whole fraction by 1, basically. But now it's going to work out for me. So watch what happens. When I multiply this across the top. Oh, hold on. My bar is a little bit too high. This should be even with the division bar here. So here's the top. This over this, multiplying by 1. So now when I multiply this whole crazy thing times this first fraction. Oh, for the love of math, the stupid thing. I can't. There's not even like a short way for me to like unfreeze it that I found yet anyway. Let's see. Just make sure that this is. Okay, we're back. Get the mouse out of the way. All righty. So where were we? We're taking the top and we're going to multiply that. So what happens is This whole thing cancels with this whole thing. So this chunk just becomes x minus 2 times 1. Isn't that just x minus 2? That wasn't so bad. Now I have to do this whole thing times my second fraction. The x minus 2's will cancel, but now I'll have this whole thing times 1. And remember, I'm subtracting it. So I'm really going to be doing minus all of it. X plus delta x minus 2. Downstairs, I'm really kind of unlucky here because nothing cancels. So I literally have x plus delta x minus 2 times x minus 2 times a delta x. Inconvenient, yes. However, now I don't have multiple fractions inside other fractions. So it's at least a little bit better. Now let's see how this thing simplifies. I'm going to have x minus 2 minus x minus delta x plus 2 up top. On the bottom, I'm actually not even going to bother to multiply all that out because I think things might cancel. I'm just going to reorder them because, I don't know, I like to go from least to greatest in terms of number of terms. Anyway, that just looks better to me. So now up top, let's see what cancels. X and negative x cancel. Yes. Minus 2 and positive 2 cancel. Yes. And look, I have a delta x and a negative delta x. Couldn't I reduce those with each other and it would just leave me that negative 1 up top? You see that? It's like math or magic. So let's do that. Those two would reduce with each other, but it would leave behind the negative 1 there. And that's pretty much as far as I can go. You could multiply out the denominator if you wanted, but you don't have to. So my final answer would just be negative 1 over x minus 2, x plus delta x minus 2. And I'm done. Oh, sorry. Oh my gosh. Was that a good question or what? I knew you'd like that one. All right. Anybody have any questions right now? So some of these will cancel out quite nicely and be relatively easy. Some will be a little bit trickier though. So what I would like for you to do, how many do we have left? From the front. There's 4 left on the front, and out of the 4, there's only 1 that's particularly bad. Okay, so we'll definitely do those 4. On the back, the first one's nice. The second one's not bad. 9's not, I mean, 9's just annoying because it's long. 11's good. How about, let's cross off number 12. That one's kind of a really long one, so we can skip that one. So if you guys would finish numbers 1 through 11 for me. We already have some of them done, but you've got a good 20 minutes in class now. Please let me know if you have any questions. I'll circulate in a bit and just let me go open this up on Jupyter. Just put all these things away here. Yes. I'm sorry, say that again. All of them except number 12. Yep. And obviously, whichever ones we did, you don't have to do them again, but all right. Okay, let's stop this thing.